Designing an alignment that refers to local standards. This tutorial demonstrates how to validate that your alignment design meets criteria specified by a local agency. Exercise 1. Drawing an alignment that refers to design criteria. In this exercise, you will use the criteria-based design tools to create an alignment that complies with specified standards. Specify design criteria for an alignment. Open Align 7a.dwg. The drawing contains a surface marked with several circles, labeled A through E. Note: ensure that Object Snap is turned on. Click Home tab, Create Design Panel, Alignment drop-down, Alignment Creation Tools. In the Create Alignment Layout dialog box, accept the default values for name and starting station. Leave the description field blank for this exercise. On the General tab, specify the following parameters: Site, Alignment Style, Design Style, Alignment Layer, C-Road, Alignment Label Set, Major, Minor and Geometry Points. On the Design Criteria tab, for starting design speed, enter 50 km per hour. This speed will be applied to the starting station of the alignment. You can add design speeds as needed to other stations. A design speed is applied to all subsequent stations until either the next station that has an assigned design speed or the alignment ending station. Select the Use Criteria-Based Design checkbox. When this option is selected, the criteria-based design tools are available. There are two checkboxes that are selected by default. Use Design Criteria File. The Design Criteria File is an XML file that contains minimum design standards for alignment and profile objects. The Design Criteria File can be customized to support local design standards for design speed, super elevation, and minimum speed, radius, and length of individual entities. The default criteria table lists the properties that are included in the default design criteria file, the location of which is displayed in the field above the default criteria table. You will learn more about the design criteria file in exercise 4, modifying a design criteria file. Use design check set. Design checks are user-defined formulas that verify alignment and profile parameters that are not contained in the design criteria file. Design checks must be included in a design check set, which is applied to an alignment or profile. In the Use Design Criteria File area, click. In the Select Design Speed Table dialog box, select Autodesk Civil 3D Metric Roadway Design Standards.xml. Click Open. Note: there are multiple design criteria files available to choose from. This exercise uses the AASHTO 2001 standards, which are provided in Autodesk Civil 3D Metric Roadway Design Standards.xml. If you select the 2004 or 2011 file, please note that you may see somewhat different values than what are shown and described in this tutorial. You will learn about creating a custom design criteria file in exercise 4, modifying a design criteria file. In the default criteria table, in the minimum radius table row, change the value to AASHTO 2001 Emax 6%. In the Use Design Check Set list, select 50 kmh roadway length checks. Click OK. This design check set contains a simple design check. You will create another design check and add it to this design check set in exercise 3, working with design checks. Draw alignment entities that meet the specified design criteria. On the Alignment Layout Tools toolbar, click Tangent. Snap to the center of circle A to specify a start point for the alignment. Stretch a line out, and specify additional pies by snapping to the center of circles B, C, and D. Then, right-click to end the horizontal alignment layout command. On the Alignment Layout Tools toolbar, click Free Spiral Curve Spiral. As prompted on the command line, click the tangent entity that enters circle B from the left. Click the tangent that exits circle B on the right. Press Enter to accept the default value of a curve solution angle that is less than 180 degrees. For radius, enter 75. Notice that the Specify Radius prompt includes a default value. This value is the minimum acceptable curve radius at the current design speed. The minimum value is contained in the minimum radius table in the design criteria file. You can enter a different value, as long as it is greater than the default minimum value that is displayed. For this exercise, you will use values that do not meet the design criteria, and then examine the results. For spiral in length, enter 25. For spiral out length, enter 25. In the Alignment Layout Tools toolbar, click the drop-down list. Click Free Curve Fillet. As prompted on the command line, click the tangent that enters circle C from the left. Click the tangent that exits from circle C on the right. Press Enter to select the default value of a curve less than 180 degrees. Press Enter to select the minimum radius of 90.000 m. Right-click to end the command. Notice that in the drawing window, symbols appear on the curve entities you created. The symbols indicate that the entities violate the specified design criteria. You will learn how to correct these violations in Exercise 2, Viewing and Correcting Alignment Design Criteria Violations. In Step 14, you accepted the minimum radius value specified in the design criteria file, yet a warning symbol is displayed on the curve. This happened because while the curve meets the design criteria specified in the design criteria file, it violates the design check that is in the design check set. You will learn how to correct design criteria and design check violations in the next exercise. Next, you will add another curve entity and examine the results. Add a sub-entity that meets design criteria. On the Alignment Layout Tools toolbar, click the drop-down list. Select More Floating Curves Floating Curve. As prompted on the command line, click the tangent entity that ends in circle D. Tip: the warning symbols do not automatically scale when you zoom in. Enter Regen on the command line to resize the warning symbols. On the command line, enter O to specify the counterclockwise direction. Enter a radius value of 200.000 m. When prompted to specify a curve length, click in the center of circle D, and then click in the center of circle E. The curve is displayed in the drawing. The length value is the distance between the 2 points that you clicked. Right-click to end the command. Notice that a warning symbol is not displayed on this curve entered in Step 4 exceeds the minimum value defined in the minimum radius table that you specified. Exercise 2, Viewing and Correcting Alignment Design Criteria Violations. In this exercise, you will examine alignment design criteria violations, and then learn how to correct a criteria violation. Check the alignment design for criteria violations. Open Align 7b.dwg. Pan and zoom until you can see circles B and C on the surface. Tip: the warning symbols do not automatically scale when you zoom in. Enter Regen on the command line to resize the warning symbols. Hover the cursor over the middle symbol in circle B. The tooltips are a convenient way to review design criteria violations in the drawing window. 2 violations are displayed in the tooltip. First, the curve does not meet the recommended minimum radius. The curve radius and minimum acceptable parameter values are both displayed. Second, the curve violates a design check that has been applied to the alignment. Notice that the name of the design check is displayed, but not the current or recommended values. Values are not displayed because design checks are custom formulas that are created by the user. If the Alignment Layout Tools toolbar is not open, select the alignment. Right-click. Click Edit Alignment Geometry. On the Alignment Layout Tools toolbar, click Alignment Grid View. In the Alignment Entities vista, in rows 2.1 through 2.3, a warning symbol appears in the No column, as well as in several other columns. Warning symbols appear next to each value that violates the design criteria that are specified in the design criteria file. In row 2.2, hover the cursor over the warning symbol in the No column. Notice that the tooltip displays the design criteria and design checks that have been violated. Hover the cursor over the warning symbol in row 4. Notice that the name of the design check that has been violated is displayed in the tooltip. Design checks are custom mathematical formulas that return either a true or false value. They indicate whether the applicable entities violate the conditions in the design check, but do not specify how to correct the violation. You will learn more about design checks in Exercise 3, Working with Design Checks. On the Alignment Layout Tools toolbar, click Sub-Entity Editor. The Alignment Layout Parameters window is displayed, containing no data. In the Alignment Entities vista, click any row for segment No. 2, which is the spiral curve spiral entity in Circle B. The design data for all three sub-entities is displayed in a 3-column table in the Alignment Layout Parameters window, where data is easy to review and edit. Notice that in the Alignment Layout Parameters window, in the Design Criteria panel, a symbol is displayed next to each design criteria property that has been violated. In the Layout Parameters panel, the Value column displays the actual parameters of each sub-entity. The Constraints column displays the design criteria values that the sub-entities must meet. A symbol is displayed next to each parameter that violates the design criteria. As is true in the Drawing window and Alignment Entities vista, the design check that has been violated is displayed, but individual parameters that violate the check are not marked. Correct design criteria violations. In the Alignment Layout Parameters window, on the Layout Parameters panel, change the spiral in length value to 33.000 m. Press Enter. Notice that the warning symbol is cleared from the spiral in length row. Change the spiral out length value to 33.000 m. Press Enter. Change the curve radius value to 100.000 m. Press Enter. The warning symbol is cleared from the curve radius row, as well as from the Alignment Entities vista. Notice that the warning symbol is still displayed on all the curve sub-entity. The curve still violates the design check. To clear the warning symbols, all sub-entities in the group must meet the values specified in both the design criteria file and the applicable design checks. In the Alignment Entities vista, in row 2.2, examine the length column. Notice that the length value is less than the value of 40 that is specified by the design check. Notice that you cannot edit the length value for this type of curve. However, you can increase the curve radius to increase the curve length. In row 2.2, change the radius value to 200.000 m. Press Enter. In the Alignment Entities vista, select row 4. In the radius column, change the value to 100.000 m. Press Enter. Exercise 3, Working with Design Checks. In this exercise, you will create an alignment design check, add the design check to a design check set, and then apply the design check set to an alignment. Create an alignment design check. Open Align7c.dwg. In Toolspace, on the Settings tab, expand the Alignment Design Checks collection. Notice that 5 collections are available. The Design Check Sets collection contains combinations of design checks. A design check must be added to a design check set before it can be applied to an alignment. The other 4 collections contain the design checks for each type of alignment entity. Each entity type has specific properties that can be checked. When you create a design check set, you specify the type of entity you want to check, and then the specific design check you want to apply to that entity. You can apply multiple design checks to each entity type. Note: the tangent intersection collection contains design checks for spiral and curve groups. Right-click the line collection. Click New. In the New Design Check dialog box, for name, enter 310M at 50 km/h. Best practice. Because design check tooltips do not display specific values, a design check name should be specific and unique. Use the mathematical formula or other specific information to simplify the process of correcting a design check violation. For description, enter tangent length must be equals 310m if design speed is equals 50 km per hour. Click Insert function. Click If. The if function is displayed in the expression field. Click Insert property. Select design speed. In the expression field, use the keypad to enter equals 50, after the property. Click Insert property. Select length. In the expression field, enter equals 310,1. The following formula should be displayed in the expression field. If. Note: in this formula, the ending numeral 1 specifies that the preceding formula is acceptable. If the entity parameters do not meet the values specified in the formula, a violation is issued. Click OK. In Tool Space, on the Settings tab, expand the Alignment Design Checks line collection. The design check you created is displayed in the line collection. Add a design check to a design check set. In Tool Space, on the Settings tab, expand the Alignment Design Checks Design Check Sets collection. Right-click the 50 km/h roadway length checks design check set. Click Edit. This is the design check set that is applied to the alignment in the current drawing. Notice that the design checks that are in the selected design check set are displayed in the Tool Space list view. Tip: to create a new, empty design check set, right-click the Design Check Sets collection and click New. In the Alignment Design Check Set dialog box, click the Design Checks tab. The table on this tab lists the design checks that are currently in the design check set. The drop-down lists above the table allow you to add design checks to the set. In the Type list, select Line. In the Line Checks list, select 310m at 50 km/h, which is the design check that you created in the previous procedure. Click Add. Click OK. If the Alignment Layout Tools toolbar is not open, select the alignment. Right-click. Click Edit Alignment Geometry. On the Alignment Layout Tools toolbar, click Alignment Grid View. Click Sub-Entity Editor. In the Alignment Entities vista, select Row 5. In the Alignment Layout Parameters dialog box, examine the length value. In the Design Checks panel, notice that a warning symbol is displayed next to the 310m at 50 km/h design check you created. In the Layout Parameters panel, notice that the length value is less than the 310 meters specified by the design check. Exercise 4, Modifying a Design Criteria File. In this exercise, you will add a radius and speed table to the design criteria file. Add a minimum radius table. Open Align 7c.dwg. In the drawing, select the alignment. Click Modifying a Design Criteria File. In this exercise, you will add a radius and speed table to the design criteria file. Add a minimum radius table. Open Align 7c.dwg. In the drawing, select the alignment. Click Alignment tab, Modify Panel Design Criteria Editor. When the Design Criteria Editor dialog box opens, it displays the design criteria for the default design criteria file. The folders on the left side of the dialog box contain tables that specify the units of measure used in the design criteria file, and design criteria tables for alignments and profiles. You can use this dialog box to modify the criteria in the current file, open another file, or create a new file. In the following steps, you will add a criteria table to an existing file, and then save the changes as a new file. On the left side of the dialog box, expand the alignments. Minimum radius tables collection. The collection contains several minimum radius tables. Right-click Minimum Radius Tables. Click New Minimum Radius Table. An empty table appears at the end of the Minimum Radius Tables collection. Double-click the new entry and replace the new minimum radius table text with local standards MEM30031. Press Enter. Save the design criteria file. Click Save As. In the Enter a File Name to Save dialog box, navigate to the My Civil 3D Tutorial Data folder. In the File Name field, enter sample local criteria.xml. Click Save. If a design criteria file must be shared by multiple users, it must be saved in a location to which all applicable users have access. If you send a drawing that uses a custom design criteria file to a user that does not have access to the shared location, then you also must send the design criteria file. Tip: when the Use Design Criteria File option is selected during alignment creation, the first design criteria found in the data/corridor design standards /folder is applied to an alignment by default. To ensure that a custom design criteria file is selected by default, make sure that its name places it first in the directory. Add criteria to a table. In the Design Criteria File Editor dialog box, on the left-hand side, ensure that the Local Standards EMAX7% table is selected. On the right-hand side of the dialog box, select the first row in the table. Click the Speed cell. Select 50 from the list. Click the Radius cell. Enter 54. Press Enter. Repeat steps 2 and 3 to add the following values to the table. Speed radius 70-125, 90-235, 110-387, 130-586. Tip: to add a row between two existing rows, click. To remove a row, click. In the comments field, enter minimum radii for 7% super elevation at various design speeds. Further exploration, expand the other collections on the left-hand side of the dialog box. Right-click the various folders and tables and examine the options that are available. Click Save and Close. When you are notified that the file has unsaved changes, click Save Changes and exit. Further exploration, use the Alignment Properties dialog box to apply the new sample local criteria.xml design criteria file and local standards EMAX7% table to the alignment in align4b.dwg.